Hello. In this program, we evaluate standard enthalpies. Welcome. Now, as we have said, enthalpy is the change in heat. Now, being the change in heat, it may occur at varied ranges of temperatures because the change in heat is normally determined by the change in temperature. What then is the meaning of standard enthalpy? The standard enthalpy of any substance represents the heat energy that is produced or yielded by 1 mole of that particular substance. Therefore, whenever we evaluate standard enthalpies, it will mean the energy that is accompanied by 1 mole of substance reacting. To represent standard enthalpy, we use the theta symbol alongside the delta H, where delta means change and theta means standard, while the H there is just heat. Therefore, standard enthalpy is the standard change in heat. Proceeding to what we have represented, we can begin by looking at what is known as the standard latent heat. Now, the standard latent heat is the least quantity of energy produced at transitional temperatures where a substance changes from a solid to a liquid or from a liquid to a gas. Remember, when a substance melts, it melts at its transition temperature without there being a change in the temperature values. For example, when ice melts, it melts at 0 degrees Celsius and the temperature remains at 0 until all the ice has changed into liquid water. On the other hand, when liquid water evaporates, it will evaporate at a constant temperature of 100 degrees Celsius, which is the transitional temperature between the liquid and the gas. And therefore, when water vaporizes, it changes into steam, and we call that the latent heat. Now, there are two forms of latent heat. One, latent heat of fusion, represents melting, and the temperature is constant. So that means delta T is 0. Latent heat of vaporization represents evaporation at constant temperature, and that is simply the change instead from liquid to gas. Therefore, latent heat is simply the heat change that is accompanied by no change in temperature, and it happens at the transitional points between solid and liquid and between liquid and gas. What is lattice energy? Lattice energy is the least quantity of energy that exists between a bond of a cation and an anion. In other words, lattice energy is the bond energy for an ionic bond. For example, when sodium combines with chlorine, sodium is the cation, which is positively charged. Chloride is the anion, which is negatively charged. The bond between the cation and the anion is the lattice energy. 3. The standard enthalpy of formation. The standard enthalpy of formation is said to be the least quantity of energy required to form 1 mole of a substance from its pure elements. For example, we saw earlier that when carbon combines with hydrogen in the presence of oxygen, the 3 species interact with one another, forming ethanol. Now, when ethanol is formed, we will balance the equation in respect to the moles present on the left and in regard to the ones on the right. And in this case, we find that 2 moles of carbon combines with 3 moles of hydrogen and half a mole of oxygen to form 1 mole of ethanol. Now, that 1 mole represents the delta H formation. Therefore, the standard enthalpy of formation is the least quantity of energy required to form 1 mole of a substance from its pure elements. And next, we have the standard enthalpy of reaction. The standard enthalpy of reaction is said to be the least quantity of energy required to form 1 mole of a gaseous product from its gaseous ions. In this case, assuming that we had potassium combining with chlorine and forming potassium chloride, now that expression will be represented as such. And when this representation is complete, you find that the product is normally a solid. But then for the reaction to occur, we agreed earlier that all the reactants have to be gaseous and they have to be ionized. So potassium will have to sublime, chlorine will have to dissociate into atoms, and they will each have to ionize. The potassium becomes positively charged, the chlorine becomes negatively charged, and when they combine, they form potassium chloride, as seen there. And therefore, the product is also gaseous. However, as you look at it, you can see clearly that the product has been represented as 2 molecules. And therefore, if say this was 500 kilojoules, then the standard enthalpy of reaction would be for 1 mole of potassium chloride, which would be 250 kilojoules. And therefore, we agree and say that the standard enthalpy of reaction is the least quantity of energy required to form exclusively 1 mole of a gaseous product from its gaseous ions. Next, we have the enthalpy of combustion. The enthalpy of combustion is simply the least quantity of energy required to completely burn 1 mole of a substance in excess oxygen. Let's take the typical example of carbon burning in excess oxygen and forming carbon dioxide. In this case, we will see clearly that there is 1 mole of a gaseous product. However, the reactant represents 1 mole of carbon. Now, carbon is a substance which is burning and burning in oxygen. Combustion is a burning of a substance in oxygen, where oxygen comes from air. And therefore, when we burn 1 mole of a substance exclusively in excess oxygen, then the process is said to be the standard enthalpy of combustion. The standard enthalpy of combustion, again, is the least quantity of energy required to completely burn 1 mole of a substance in excess oxygen. Next, we have the enthalpy of solution. A solution comes from the idea of dissolving. Therefore, we can say that the standard enthalpy of solution is the least quantity of energy required to completely dissolve 1 mole of a substance in water. For example, when we have HCl and a solvent such as water, which is H2O, we will end up forming HCl, solvent forming HCl aqueous, assuming it was HCl gas. So the least quantity of energy required to completely dissolve 1 mole of HCl gas in water represents the standard enthalpy of solution. Next, we have the standard enthalpy of neutralization. Neutralization is simply a process in which an acid, such as HCl, combines with an alkali, such as sodium hydroxide, and they form a salt, such as sodium chloride, and water. Therefore, we can agree and say that neutralization is a reaction between an acid and a base, forming salt and water. So acid and base forming salt and water represents the process of neutralization. Remember, during neutralization, hydrogen ions from an acid combine with hydroxyl ions. Hydrogen ions from an acid combine with hydroxyl ions, forming H2O, which is a neutral substance. Hence the term neutralization. And therefore, comfortably we could say that standard enthalpy of neutralization is the least quantity of energy required to completely dissolve 1 mole of an acid in an alkali, forming a salt and water. It could also be the reverse, that standard enthalpy of neutralization is the least quantity of energy required to completely dissolve 1 mole of a base in an acid. So, we have said, and I wish to reiterate, that anytime we use the term standard, we represent it by the theta symbol. And if it is standard enthalpy, then we use delta H theta. Delta is change, H is heat, and theta is standard. So standard delta H means standard enthalpy. Conclusively, we have agreed that enthalpy standard lattice occurs at transitional temperatures, that is without change in temperature. Lattice, we have said, is the heat energy between cations and anions in ionic compounds. Formation, we have said, is the formation of 1 mole of a substance from its pure elements. Reaction, we have said, is the combining of gaseous ions to form 1 mole of a substance. Combustion, we have said, is the burning of 1 mole of a substance in excess oxygen. Solution, we have said, is the dissolving of a substance in a solvent representing 1 mole of the reactant. And neutralization, we have said, is the combining of an alkali with an acid to form a salt and water. Thank you.